Hello, welcome to this second introductory film from the IB chemistry course. This one makes some comparisons with the first film about covalent molecules, so hopefully you've seen that one before you watch this one. And hopefully, by the end of this film, you'll understand, again, how we can decide if a compound is ionic or covalent. We'll be able to look at the ions present in a formula to decide the name of an ionic compound. And you'll be able to use the formulae of ions to determine the formula of an ionic compound. Okay, so as I say, there's some comparisons made with the previous film, so hopefully you've watched that one before you start this one. And this might seem familiar from that first film. Here we've got our periodic table again, which shows us where the metals and non-metals are in the periodic table. Remember that we said that covalent substances are made of non-metals joined together. Okay. In the case of ionic compounds, we mentioned this in the last film, but it's really important to remember it, so perhaps make a note about it during this film. Okay, that ionic compounds are made of any metal joined together with a non-metal. And there is just something we need to watch out for, because there is a positive ion. So metals are always positive ions, right? But there is a positive ion that doesn't have any metals in it, and that's the ammonium ion. Okay, so if you ever see a compound with the ammonium ion in, it will be bonded to a negative ion, which will be a non-metal, and it will look like there aren't any metals there. Okay, but it is still ionic. So the only exception to the rule that ionic compounds will always have metals joined to non-metals is any substance that's got ammonium ions in. So there's the ammonium ions formula. Watch out for it. Okay. Now, getting the name from the formula is a little bit simpler, in a sense, than with covalent substances, because we don't have to bother with this prefix system. We just say the ions that we see. We don't have to say how many of them there are. The reason this is perhaps a little bit more difficult now is because we can't just get the names of the ions from the periodic table always, all right? Because some ions are a bit more complicated than that. So we have to remember our list of ions, okay? If you can't remember your list of ions, you won't be able to name these compounds, and everything in chemistry can suddenly seem very, very difficult. I really can't overestimate how important it is for you to remember your list of ions. Anyway, here's a sodium ion joined to a chloride ion, so quite simply the name of this substance is sodium chloride. Now, if this next compound was covalent, which it's not because it's got a metal in it, it would be called dipotassium monoxide, but we don't have to bother saying how many of each ion there is. Okay, we just call it by the names of the ions that are in it, so potassium oxide. This one's got 2 aluminiums and 3 oxygens, but we don't have to worry about how many there are when we're coming up with its name. We just call it aluminium because it's got aluminium ions in, and aluminium oxide because it's got oxide ions in. Now, here's where it gets, so far I suppose these have been all from the periodic table. This one is a little bit trickier because here we've got an ion that's made of more than one atom. And so we have to remember its name because it's not in the periodic table. And that's called a sulfate ion, which you can see from your ion list. So this compound will be called calcium sulfate. Certainly not something like calcium sulfur tetraoxide, okay, because it's not covalent, it's got a metal. Here's magnesium nitrate. You have to remember that this collection of atoms here is a nitrate ion. Magnesium nitrate. And you can see immediately how difficult this is going to be if you can't remember the names of these ions. Now here's a substance that doesn't have a metal in, so perhaps it's not ionic. But remember, here's our ammonium ion. So this is just ammonium, and H4+ is the ammonium ion. It's with a Br- ion, which is called bromide. Okay, here's iron with 3 chlorines attached, but I don't have to say how many there are. But I can't just call this iron chloride, unfortunately, because there are some metals that can form more than one kind of ion. So usually, as a general rule, if your metal is in that central section of the periodic table, called the transition metals, then you have to say what charge the metal ion has got on it. Iron can be either 2+ or 3+, so we can't just call this iron chloride. We have to call it iron 3 chloride, so we're making it clear what the charge on the iron ion is. All right, so remember that there's a little quirk there. In fact, perhaps if I just show you the periodic table and I can show you the part we're talking about. That part there, the transition metals, if your metal's found in there, you need to say what oxidation state it's in or what charge is on its ion. Okay, now moving on. I'll just skip that slide. Moving on to turning a name into a formula, now we have to balance charges. So this is simple in the sense that we just get the names of the ions and put them together, but a little bit more complicated because now we have to make sure that the charge is balanced. You should already be able to do this by the time you start the IB course, but just a little reminder, if I've got a lithium plus ion and a fluoride ion, if I don't know what their formulas are, because I haven't learned the ion list, I can't possibly decide what the formula of this compound is going to be, but I need one of each of these ions because they've both got 1+ or a single charge, so the charges cancel out by having one of each, and the formula is LiF. Magnesium has got a 2+ charge, whereas chloride has got a 1-. So to get those two charges to balance, I need 2 chloride ions. So the formula of magnesium chloride is MgCl2. Again, I would have no chance of getting that formula right if I didn't know the charges of the ions. Calcium has got a 2+ charge, oxide's got a 2- charge. I only need one of each of those to get them to cancel, so the formula is CaO. Sodium sulfate, that's got a single plus ion, and a sulfate ion, which is one of the ones we have to remember, is a 2- ion, so I need 2 of the sodiums for every one of the sulfates, Na2SO4. Barium nitrate has a Ba2+ ion in, and an NO3 1- ion. So the nitrate ion has 1 nitrogen, 3 oxygens, and a single minus charge. That means I need 2 of them to go with a barium ion. But because there's a number of atoms here, if I just put a 2 straight after it, it would turn into NO32. So I have to put that ion into brackets to show that there's 2 of that whole ion. Okay, and just finally we'll finish off with aluminium carbonate. That's got an Al3+ ion, carbonate ion, which is CO3 2-. Now in this case I need to multiply both the ions. So I need 2 of the aluminiums to get 6+, 3 of the carbonates to get 6-, so it will be Al2, and I've got to put the carbonate ion in brackets because I've got to show that there's more than one of that whole ion. That was quite quick, but remember you can just pause it and go back and see it again. And of course, if you've got any questions, you can come and ask me about it, okay? So it's really important that you feel that by the end of this film you can do these things here. If you don't, come and ask for some help or post a comment on the YouTube page, because as I've said before, that's really useful for other people to see the questions that have been asked and what the answers are.